Sequences and series, okay? Sequences are not really something new to you. You just might not have called them sequence. At some point, you guys have all had the question of, hey, here's some numbers. What's the pattern? Can you figure out the next number or the next couple numbers? I know they do it in geometry a little bit. They just don't call it a sequence. So my sequence here is 3, 6, 12, 24, 48. What's happening is that we're taking these numbers and we're multiplying them all by 2. So you could get the next number in the sequence by multiplying the last number by 2. Now this is a certain form of a sequence we'll talk about a little bit. But in terms of equations, we were used to domains being x. Well, that's no more. We're actually going to replace it with an n. And n means it's basically the position in the sequence. Okay, and range, which was y in the past, we're going to take that out. And it's going to be this little a and with a little n. That's going to be the term or the number in a certain position. Okay, so what we're going to do is we're going to write the equation based off of those positions. Now, here's two possibilities. It could either be finite, so that it ends, or it could be infinite. It could go on forever. We're basically going to talk about finite ones, even though they might be ... We're going to kind of stop it. But here's what I mean by a rule. So a with a little n, I call it a sub 1. This is talking about the term you would get if you were to put n is some, like, I shouldn't say number of term, more better way of putting it would be like position. So a with the little 1 means I want the first term or the first position. So I take 3 times 1 and the first number in my sequence would be 3. I put in a 2, 3 times 2 is 6, so the next one would be 6. I put in a 3, so 3 times 3 would give me 9, and so on. So if I put in 40, 3 times 40 means if I keep on going to the 40th position, and that would be n is equal to 40, I would see the number 120. So that a with that little 40, kind of in a built-in way, is telling me two things. It's telling me I want the term, but in that spot. So the first one we're going to talk about is a special type of sequence. It's called geometric sequence. And here's the why we're talking about this one first. We just got talking about exponential growth. So y equals a b x minus 1. We're just going to replace the y with a sub n. The b is going to be an r, and I'll talk about r here in a little bit. A is going to be the a sub 1. So basically, we need the first term of the sequence, and this r is called the common ratio. The common ratio is the number that you keep on multiplying by. So in my first example, I multiplied by 2 over and over and over. My r would be 2. Now, it's called a common ratio because I take the second number divided by the first number, and that ratio or fraction works out to be 2. So here we go. Let's talk about some here. My common ratio, and this is what I mean, I could take negative 8 over 4. I get negative 2. Take 16 over negative 8. I get negative 2. Take negative 32 over 16. I get negative 2. That means r is negative 2. Is it geometric? Yes, because my common ratio is negative 2. Or essentially, I'm multiplying by negative 2 again and again to get to the next term. Okay, the second one looks like it because I'm multiplying by 3, but all of a sudden it switches off to a negative 3. Well, that's not the same thing, so it's not geometric, and it's not going to be that type of sequence. It could still be a sequence, it's just not a geometric sequence. So here we go. Let's write a rule, and here we're decreasing, so I know I need to multiply by a number smaller than 1. To figure out that number, what I could do is I could take 2 over 5. I get 0.4. Double check. 0.8 over 2, hey, that's also 0.4. 0.32 over 0.8, that's also 0.4. So I have a common ratio of 0.4. Now the other thing I need is my first number, which is 5. So my rule for any specific spot would be 5, and I like to put my ratios or common ratios in parentheses, the n minus 1. So if I want a with this little 1, this is basically saying find the number in the 8th spot or position. So if I were to keep this going to the 8th spot, I want to know that number. So, oops, sorry about that, guy. Keeping you guys awake. I'm going to put in n is equal to 8 into that formula I just came up with. So 8 minus 1 is 7, so I'm going to take 0.4 to the 7th power, and then multiply by that 5, and I got a value of 0.008192. How is it smaller? Well, we talked about it, exponential decay. You know it's exponential decay if that r is smaller than 1 and 0.4 is smaller than 1. Okay, let's come up with a sequence. Now, what I'm going to do is I'm going to basically come up with a system of 2 equations. So here, this is really telling me 2 things. I know that the second number is 4, or negative 4. So I know that n is equal to 2. Same thing here, I know n is equal to 6, and that would give me negative 1024. So equation number 1, okay, negative 4 equals a sub 1, r to the 2 minus 1 power. Oh yeah, by the way, a1 and r is what I'm trying to find here. Equation number 2, okay, so a sub 1, r to the 6 minus 1. Okay, so what I'm going to do is I'm going to pick one equation. I'm going to pick the top one here, and I'm going to get a sub 1 by itself. So I'm going to divide both sides by r to the first power, because 2 minus 1 is 1. Now, in substitution, I'm going to take this red equation I just came up with, and I'm going to put it into my original other equation wherever I saw a sub 1. So I've got a new equation with negative 1024 equals, and then again r to the 5th, which over 1, those r's would cancel out, r to the 4th. Divide by a negative 4, and I've got r to the 4th. Let's see, 1024 divided by 4, 256, and because we just have the 4th power, I'm going to take the 4th root of both sides. R is equal to 4, so my common ratio is 4. Now to find a1, I'll take the 4, and I'll put it into this fraction here, and I get negative 1. So my rule would be the first number here, and my ratio right there to the n minus 1 power. And there's my geometric sequence. And there you go. I hope that helped out, but if not, just kind of rewatch it or ask some questions in class.